Hi there, and welcome to Ian's Engage channel. I'm Ian. May I firstly apologise for my voice, which appears to be cracking up as I record this. In previous videos I've shown locos running around my test track on both DC and DCC. I've done this by connecting the DCC bus to the test track and then powering the bus using either a DC controller or one of my DCC command stations. However, as I need to add DCC only components to the DCC bus, such as autofrogs and the servo controllers, I need a way of separating the DCC bus from the test track, while retaining the ability to run DC and DCC locos on it. In this video I'll show how I've enabled the test track to be controlled by DC or DCC by keeping it separate from the DCC bus. The DCC bus is the lifeblood of the model railway, and as such it will always be powered by a DCC command station. That hasn't been the case up to now, where I've been able to connect DC or DCC power to the bus, which I've done using a system of spring connectors. Having the ability to power the bus using DC or DCC has been fantastic, as it gives the ability to control DC or DCC fitted locos. However, as I start to connect more electronics to the DCC bus, such as servo controllers, autofrogs and accessory decoders, I'll no longer be able to connect DC power to it, as this would damage the DCC components. So the plan is to divorce the test track from the DCC bus, but in such a way that DC and DCC power can still be provided to the test track. The test track won't live on this baseboard forever, but while it can, it's a convenient way of testing locos, running them in, and, of course, it's a way to play trains while I'm building Shelfington. Currently, there is only one set of dropper wires that power the whole of the test track, and these are connected to the DCC bus via a lever nut connector. While swapping controllers via the spring-loaded connectors has worked well in terms of functionality, they aren't the most convenient way of switching between power feeds, and there's sometimes been confusion as to which controller was actually connected to the bus, as the connections were usually made out of sight beneath the baseboard. To remedy the connection confusion, I'm going to use two clearly labelled power jack plugs and sockets that are mounted to the baseboard framework. One socket will be connected directly to the test track, and the other socket will be connected directly to the DCC bus. Both sockets will use Wago inline connectors to make their respective connections. I'll then connect jack plugs to the tail wires of both of my DCC command stations and the DC controller. The plugs from all three controllers will then be able to be used in the test track socket, while either of the DCC command stations will be able to be used in the DCC bus socket. This solution not only gives me the ability to run DC or DCC locos on the test track, but it also gives me the ability to run locos on both the test track and the DCC bus feed simultaneously, which is something that wasn't previously possible. So now there was a plan, it was time to put it into action. I decided to start with preparing the jack plug for my DC controller, which was a Gagemaster combi unit. I was also trying out a new flux paste to me from Leco, which had been given to me by a friend. It had also been recommended by Stephen at Elvenholm. I usually used DCC Concepts liquid flux, and while that was excellent, it sometimes ran into areas where I didn't want the solder to go. Being a flux paste, the Leco flux could be applied to a specific area using a toothpick, and stayed where it was placed. For soldering, I set the iron to 410 degrees centigrade, as this seemed to heat the metal connector sufficiently to take the solder from the tip of the iron. I started off by making sure there wasn't too much bare wire showing before applying flux and tinning with solder. I wanted the jack plug to be centre pin positive and was using 16 gauge wire, which was the same gauge as I was using for the DCC bus. However, this caused a problem. Two 16 gauge wires were too thick to go through the hole in the sleeve of the jack plug. This meant that I had to modify the sleeve by snipping off the end part. I also put some small cuts into the end of the sleeve so it could open up a little more if it needed to. This small modification would allow both wires to slip through the sleeve and meant that I didn't need to source different connectors. The approach I took to soldering wires to the plug was similar to the one I used for soldering wire to the bottom of rails. I added solder pads to the inner and outer connectors of the plug using a piece of blue tack to keep the jack plug steady. I added flux to the connectors, then put some solder on my iron, then introduced the iron to the connector. The solder then flowed nicely through the flux and onto the connector. To connect the wires to the jack plug, it was then a simple job of bringing each wire to the appropriate solder pad and introducing heat. This formed a very strong bond between the wire and its connector. The next step was to test if my soldering had done the job electrically. This meant using my multimeter to check that the red wire was connected to the centre of the jack plug, and then I checked that the black wire was connected to the outer part of the jack plug. Once this was confirmed, I attached the wires back up to the DC controller. It was then time to move on to the test track socket. Adding wires to the socket was a similar process to adding them to the jack plug. I created solder pads on the socket, then tinned the wires, then joined the wires to the socket. I then made up the socket with the rest of its components. I finally joined the jack plug and the socket together for safekeeping. Before I went any further, I thought it would be a good idea to see how difficult it would be to fit a socket to the baseboard framework. I started out by measuring the socket diameter, which was probably in some imperial measurement, as I got 10.85mm, so it was too big for a 10mm drill and too small for an 11mm drill. That meant that some filing would be required to increase the diameter of a 10mm hole. At this point, I decided that I would add the sockets to the balsa wood panel I'd made for my power cab, as filing balsa wood would be a lot easier than filing the plywood of the baseboard framework. However, before I destroyed the balsa wood panel I'd already made, I'd thought I'd have a test run on an old piece of balsa wood. Unfortunately, I managed to knock the camera while I was drilling and filing the hole, so I don't have any footage of that, and this is just me finishing off the test fit. Now that I was happy that I'd be able to install the sockets, I pressed on and added wires to the DCC socket and power jacks for my DCC controllers. I used the same principle as I'd done for the DC controller jack and the test track socket. One issue that I hadn't considered was with the blue tack I was using to keep the connectors in place while I soldered them. It got so hot that it became ineffective after a while. One of the jack plugs was connected to the tail wires of my power cab, so in order to test for electrical connectivity, I had to remove the plug so I could attach my multimeter. Once my soldering had passed the beep test, I could then reconnect the plug and get ready to prepare the power cab panel to install the sockets. Firstly, I measured up where I was going to drill the holes, roughly marking positions using a Sharpie marker pen. I then unscrewed the power cab interface panel as I didn't want it to be damaged during the drilling process. Once again, I managed to miss the actual process of drilling holes in the power cab panel. This time because I forgot to press the record button. Oh well. Also, I hadn't been happy with the DCC socket I'd prepared earlier, so I decided to prepare another one, and this time I added a bit of shrink wrap to the positive wire as the wires were coming perilously close to one another. I then fixed the socket to the balsa wood and clipped inline Wago connectors to each wire. Next, I reattached the power cab's interface panel by screwing it back into place. I then fixed the test track socket in place, again applying the Wago connectors to the wire tails. The power cab panel was then taken to the train room and fitted back onto the baseboard framework. Now that I'd installed the power cab panel back in the train room, it was time to test if I'd connected everything up correctly. I'd labelled the sockets on the power cab panel and had connected my power cab to the DCC bus socket and my DC controller to the test track socket. I put the large Prairie onto the test track and the ever dependable Class 33 onto the tricky bit, which was connected to the DCC bus. I then set the large Prairie circulating the test track. And off it goes. Excellent. While the large Prairie was strutting its stuff, I used the power cab to shuffle the Class 33 along the tricky bit. And isn't that fantastic? It had been a long time since I'd last had two locos running simultaneously in the train room. The final test was to plug my Yamaha YD7001 DCC controller into the test track socket and replace the large Prairie with a DCC fitted Class 50. I could then operate the test track on DCC using my Wi-Fi throttle, while the power cab still controlled the 33. How fantastic was that? I also have a plan for the future to add some extra sockets around the layout that will allow me to pinch some power from the DCC bus in order to temporarily connect experiments to it. This would have come in handy when I was testing out Code 55 track, or testing servos, or autofrogs when I had them on separate small baseboards. Okay, so that's about it for this update. I'm incredibly pleased how this has turned out. Separating the DCC bus power from the test track will allow me to make progress in so many areas where I want to install components that will only operate on DCC. For instance, I'll now be able to install the autofrogs, the servo controllers, some accessory decoders, and the bus spike suppressors. I'll also be able to think more about block detection and current sensing devices. The best thing though is that I'll still have access to my test track, so we'll be able to play trains for a while longer until I complete the work on the tricky bit. As usual, let me know what you think. Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a beginner in N-Gauge modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress soon. Bye.